So welcome all students for this today's lecture, Geomatics and 3D visualization of surface, subsurface architecture of Cauvery Basin. That is, it is case study from Tamil Nadu, that is where your river Cauvery is there in deltaic region. Specially this case study is highlighted for that I have written as case study, a special case study for hydrocarbon exploration. Okay. As in the background, I have given two images. One is your surface image and another is your subsurface image. So depending upon that, today's lecture will have some key points. So these are the lecture objectives that we will start with introduction, that means why such type of river delta is there and what is the necessity for hydrocarbon exploration and what is the application of remote sensing and GIS in the field of hydrocarbon exploration. Then study of surface architecture, that means surface signature using the satellite imageries or the identify the surface signature or the surface architecture from this satellite imagery or the digital imageries. Then study of subsurface architecture using resistivity and gravity data. Then I will emphasize mostly on the SSS, okay, that is the science of shallow subsurface. I will emphasize that one because in this new era, why all the people are looking for this science of shallow surface studies and what is this the major application parts. Okay. Then depending upon this case study, whatever the broad methodology have derived for find out the such type of hydrocarbon exploration and finally if you are going for the such type of methodology, then what is the they have derived, because they have, it is a case study, I am taking the different persons, they have already worked with this region and they have derived a model, and such type of model whether it is essential for any other regions or not, if it is, then what is its impact factor or what is the socio-economic benefits. Okay. And finally, depending upon all the things, the criteria, whenever we will amalgam all the things, then the result and the discussions will come after from that model derivations. So coming to this introduction parts, because all of you know that any nation's economic status, that means any nation's wealth and its prospects and the progress, it depends upon primarily upon the natural resources, ecological status and natural disaster vulnerability. Because and this nature related prospects, where you will get that prospects and the problems depend upon the surface and the subsurface geological process, because below the subsurface certain geological process is ongoing. Once if you are having the satellite imagery, from this satellite imageries you are identifying the surface signatures. Okay. Then in the process of subsurface identification, so as I mentioned, that is the SSS studies, that is your science of shallow subsurface. So the science of shallow subsurface, what it indicates that below the subsurface up to 100-meter depth, whatever the structure is there, it will be identified, and such type of study is known as the science of shallow subsurface or the science of shallow subsurface studies. Then another thing, deep subsurface studies up to 5-kilometer depth, whatever the layers or the whatever the structures are present, then you can identify from that deep subsurface studies. For this shallow subsurface studies, we are using the resistivity method, and for this deep subsurface study we are using gravity method. Okay. These are the two methods where we are bringing all the things from the surface to the, that means we are keeping in the 3D view. That means we want to know whatever the surface signatures and subsurface signatures are there. They are taking this 100-meter depth or taking this 5-kilometer depth. Within this 5-kilometer depth, whatever the structures are present. Then particularly coming to this case study, the tectonic, fluvial and the coastal geomorphic anomalies are helpful in understanding the surface geological processes, the geological resistivity, gravity, seismic and borehole data are helpful in understanding the subsurface geology of that area. In a particular area, if you are going, you are identify the surface signature if you are having the satellite imagery or aerial photograph or any image of that area. You are identifying the surface signature. But for that subsurface study, you are taking the resistivity data up to the shallow subsurface depth up to 100 meter depth. Then you are taking the gravity data maybe that is within the 5 kilometer depth, and if it is the borehole data, that means the identification of the different layers, the different structures present below the subsurface of the earth. Okay. Then so as I taken the case study for this Cauvery region, as I mentioned there, in many deltas including the Cauvery, because Cauvery river is there and it is having broad delta surface is there. So in many deltas including the Cauvery, delta has been studied for sedimentation, because once the erosional activities is there, such type of erosional activities through the process of the different types of rivers, when all the erosion materials are eroded materials are coming and deposited near to that coastal area, that means near to the ocean area, the deposition, that what we are calling the sedimentation, that means layer by layer it is deposited on the, that means near to that oceans or the near to that sea level, sea area, that means what we are calling the delta, and the process, the layer by the layer formations is called as the sedimentation process. And once again it is having the isostatic changes and the eustatic changes. Then it is the question is coming to everyone's mind, what is the isostatic changes and what is eustatic changes? Isostatic changes is the local phenomenon. So in that local phenomenon may be due to there are the some physical criteria, the physical factors are there, may be due to that uplifting or the seismicity or the seismic, the earthquake occurring for that particular area, that means what I am calling seismicity. And once again another is ice. But whenever we are coming to this Indian continent, particularly this southern India portions, that is whatever the Tamil Nadu is situated, southern Indian portion, so these two things is highlighting, that is your uplifting and the seismicity. As far as the zonation of earthquake, that is your earthquake atlas map is concerned, this total Tamil Nadu area, some part coming this Cauvery delta area, it is coming zone 3 and zone 4 area, that means which is having some moderate to and some high zone of seismicity intensity area is coming in that particular area. Then coming to this eustatic changes, it is a global phenomenon. In that global phenomenon, the factors like your global warming, due to that such type of global warming, you are having the sea level rises. So such type of, for particular region, we have analyzed the isostatic and the eustatic changes, that means compared to the sea level rises. Per year it is having the sea level rise is 0.04 millimeter. Every day that is, in the sea level is rising. Then the question is coming, why such type of sea level is coming, sea level is rising? As I told you, due to the eustatic process or the eustatic changes or the isostatic changes, and these are the some of the factors which depends upon the such type of the changes. And once again it is the play the fluvial and the marine interplays. Once you are having some river systems, that river system is coming, and whatever this river system is coming and it is interact with the oceans. So once this river water and from this, that is your ocean, that the marine water, that means in between there is the some interplays, and within that processes also there is the formation of the different land types. So in that land types, maybe your beach, the beach ridges, or the sometimes the swell complex, all the things are coming in that, the whenever that fluvial and the marine interactive. And such type of environment and environmental characteristics and all the that is depending upon the marshy area and the habitat, for which purposes the such type of things are occurring. Then another thing why I am putting that red color, both the surface geology and its significances in the surface have direct control over the resources. Environmental and hazards are not studied much, because whatever the surface things are there, only it is highlighted whenever you are analyzing the such type of analysis, that means taking consider whether it is you are having aerial photographs or the satellite imagery, all the resources you are getting, but nobody is bothering about this environmental and the hazard mapping. Okay, so this is the one case we have considered. Then the same is the attempt for the Cauvery Delta by analyzing surface signatures and subsurface architecture using the tectonic, fluvial and coastal geomorphic anomalies and gravity, resistivity and the borehole data, etc. Because in the next slide I will tell you what are the aims and objective of these case studies, what we have to brought out, or for which purpose the such type of case study is carried out. Because one of the professor, that is the DST chairperson, Professor S.M. Ramaswamy, and my professor, Professor J. Saranavel, and myself were included this DST project. This is the one of our case study that is available in that online also. You will get all the materials from that one. Okay, so taking that one.
How occurrence of the resources depends upon the subsurface geology?
Yes, just wait, I will come to that one. In that subsurface geology, because you don't know there is the presence of because as I told you that case studies emphasize, I am emphasizing one particular case, whether the geology depending upon the geological characteristics or geological layers or geological formation, which type of formation is required for which purpose. Okay, for petroleum deposit or the hydrocarbon exploration, it needs some structures, well developed structures. So from that structure only we will bring out, or for the groundwater occurrences, because these are the some resources. Taking that resources, how the remote sensing and GIS helpful to bring out that structures. And same, and the meanwhile we are going for this resistivity as well as the borehole data. In the resistivity data, because you know that wherever the less resistivity, that indicates that is the high conductivity. Less resistivity it will come high conductivity, that is the presence of directly evidence that you will get the groundwater potential zone within that area. Okay, so in that resistivity, whenever coming to the hydrocarbon exploration, because I have already prepared the maps, I will show you how you are getting the high zones and the low zones, and how we are marking the lineaments. Okay, all the things I will discuss here. Okay, so the aims and objective of this case study is visualization of the surface signature or the structure by analyzing the tectonic, geomorphic and drainage anomalies from the satellite imagery. That means what we will get the surface architecture. Then visualization of subsurface by analyzing the resistivity and the gravity data. Then identification, then I am underlining this thing, identification of possible linkage between the subsurface and the surface, because whether there is a positive correlation or not, or someone is coming the positive and something is coming the negative. So what is the drastic changes? We will bring out that structures. Then to bring out the total architecture of surface and the subsurface. Then the main important thing, whether you are going for identifying anything, whether such type of research is useful for society or not. And the society proposes, or the benefit proposes, to find out the hydrocarbon locales, where the such type of environment is there, and how to find the hydrocarbon locales or the hydrocarbon deposits in that particular area. Particularly for this hydrocarbon locales, whenever you are having the depositional environment. So for that depositional environment, you are having the very dead plants and the animals, and it is having interacting with this marine and this fluvial, and the layer by layer the depositions are there. So over a period of time, if that such type of deposition is there, that indicates that there is the formation of the carbons, that is the methanes and propane, all the things. Okay, so from that only if you will identify the such zones, then you will identify the hydrocarbon locales. So for that purpose only, if you are going for, we have already derived a model. So how the such model is working to identify the such type of hydrocarbon locales, and what is the relation, two important things, what is the that is the correlation between or the possible linkage between surface to subsurface, and find out the hydrocarbon locales. Okay, depending as you asked, how you know the geological formations, because most of the geologists depending upon the geological stratum, whether it is the particularly such type of environment will come for the hydrocarbon locales when you are having the sedimentation, much more sedimentation and a depositional environment. And another case, if you are having the favorable structure, maybe the anticline or the domal structure, from this that means the highest will come. In that area, whatever the due to the Binance effect, all the oil, water, like that, all the things, gases, it will be trapped there and it will migrate to this direction. When you dig, all the things will come. And for this trap proposes, in geology we are using the traps and the structures to identify the such type of hydrocarbon exploration. Okay. Okay, this is your key map, India map, where the state map Tamil Nadu is coming, and the portion of that Cauvery Delta we have taken. So in that base map, particularly as I told you in the GIS, how to prepare the base map. Base map is the reference map. In that reference map, you just see that there is having some certain locations or the certain settlements are there, the names are coming, then drainage, some drainage patterns, and some are the road networks. See, in that base map, like your Chidambaram is the upper portion is coming, and that is the point of the next one, last point, like the Bedaram and all the things. Some certain locations, and it is having connected with the some road networking and the some drainage patterns. Okay, and it is lies in between the some latitude and the longitudes. Okay, that is your latitude and longitude, it is right. Okay, so in that the latitude, it is longitude that lies in between 79 degree 15 minute east to 80 degree 0 minute east, and the latitude of 10 degree 25 minute to 11 degree 15 minute north. The study extends from Kolerenu in the north to Agner in the south, because the Kolerenu river is in the present in the upper portion of this, that is where the present, you see that one river I have demarcated here, that river, that present river, and the Kolerenu river is here, and whenever you are coming to this lower part, that Agner river, that means starting from this north and the south, and subsequently there is so many rivers are there, and it is the changing is the characteristics. I will show you how the rivers are changing its the characteristics, and for this purpose, what is the local phenomenon or global phenomenon it is acting, whether it is having some tectonic movement or some seismic activity zone, or the depending upon the fault zone, whether the north south, the different types of lineament we are marking. I will tell you how we are marking all the things. Then once again, the study area displays the tectonic geomorphic picture of the uplands in the western part. I will show in the satellite imageries, and a huge delta and the associated fluvial landforms in the center and the marine landforms in the east portions. Because as I shown in this very beginning of the slide, the satellite imagery of this Cauvery region, we will see that the two portions are there, uplands. Then in between there is a huge arcuate delta. Arcuate, it comes from this, the shape of arc. The arcuate delta, the name is coming, that is arcuate broad, arcuate delta. Then some marine deposits are there. Then it is coming that in the eastern part there is the ocean, that is your Bay of Bengal. And owing to this hydrocarbon potential and unique geomorphic landforms, the area have been comparatively well studied. Because I have written this one in the year of 1984 and year of 1987, Agarwal and Mitra, there is the authors, they have already identified the such type of hydrocarbon zones, but they have not considered the subsurface lithology. Only from that surface signatures they have identified. But in our model, what we have suggested, we have taken the subsurface lithologies which is having some correlation, it is coming in that particular area to bring out the total architecture. Okay. Yes, this is the broad methodology how the GIS and the remote sensing is helpful to find out the possible linkages or to find out the hydrocarbon locales. Now it is divided into, the methodology divided into 3 parts. In the first part, the preparation of various thematic layers from the satellite and the collateral data. From the satellite and the collateral data means that is you are having toposheet or the borehole or whatever it may be. That is ancillary data is what we are calling. And from this satellite or the collateral data, the base map, drainage map, lineament map, geology map and geomorphology map is coming. So particularly coming this, the 5 types of themes or the 5 types of layers, drainage, lineament, geology and geomorphology, it is having direct control over the surface. Sometimes you will see that the one block is going up, another block is going down. So whenever you will map the lineament, as I told you, what is a lineament? Anybody? What is a lineament? We already discussed what is a lineament. Linear or curvilinear features which is having tectonic origin, which is having some natural occurrences, the natural origins, or say for that tectonic origins, that is your lineament. Then that lineament, how it is having control over the surface, and same while, that means whenever you will go to the subsurface or the deep subsurface, the such type of lineament is controlling over the subsurface or the surface or not. If it is having some controls, that indicates that there is some correlation between the surface to subsurface. Okay, we will study all the things, how the lineament is varying, and same the drainage also. Whatever the drainage structures you will see, say in the drainage structure sometimes whatever the different types of, if I will consider this is the area and all drainages are coming, suppose these directions, all are coming to these directions. That means whatever the water flow lines, all are coming to this center. This is a one kind of pattern is there, and another when the drainages are away from these centers, 2 things will come. So in case, suppose if a structure will be developed like that, what I am calling the ridge or the domal structure. So such type of domal or ridge structure, if you will put some water, what will be happen? Automatically it will go in the different directions. So same, if that drainage is developed from this origin, that means due to the rain or whatever it may be, depending upon the slopes, as it is a high mounted or elevated area and it is having some slopes, automatically it will go in this in the different directions. But in case of this, the basins, what we are calling the shashur shape or whatever it may be, some geological terms are there. Whenever the drainages will come, that means it will come towards the center. In the case dome or the basin, that is the dome or the ridge structures, drainage lines, it will away from this center. If we put water, it will away from this center. But in that case, if we put the waters, it will towards the center. Okay, these are 2 structures. That 2 structures is the most prominent role to identify the such type of hydrocarbon or maybe the groundwater resources. Then from this drainage and the geomorphology, then it brings out the different types of surface geomorphic anomalies. That means how it is different from others. How is it different from others? So in a classroom, if you are sitting silently and somebody is disturbing, okay, so that consider means how he is different from others. So in that geomorphology map, what is the geomorphology map or what is geomorphology? I already told what is geomorphology.
Materials that are found in the ground.
No, that is your sedimentation process. Scientific landforms, whatever the landforms produced by the natural occurrences. Say any tectonic movement is occurring. So one area will be uplifted and other area will go down. Or in that river process, your river is there, your active channel is there where the flow of water, and control the near to that area you will have some floodplain area. Then that depositional environment, whether it is having whether it is a mountains area, so whenever it is coming to the near to that mountains area, whatever the types of the deposit, that pediplain or the pediment surface. So coming to this, the geomorphological characteristics and the landforms, and particularly for this geomorphological characteristics and identification of the different types of landforms, particularly it is highlighted the fluvio and the marine, because as it is comes under that is a river system and it is near to that marine environment. All the landforms will be produced by the river and the oceans. That is the dominant features you will, that means we already identified from this geomorphological map. Then different types of anomalies and is the surface structures, amalgaming all the anomalies to bring out the structures, surface structures. Then the collection of the resistivity data and the gravity data and the borehole data. From this resistivity data, the creation of DEM. What is DEM? DEM, DEM. Digital elevation model. So particularly why it is required, whenever you are going for this subsurface, you want to bring that whatever the structure is present in the 3D, you have to represent in the surface, that is the digital elevation models. So from this digital elevation models, we have created the analysis of the different resistivity layers, brought out the shallow subsurface structures, and analysis of gravity data. From this gravity data to brought out the deep subsurface structures, then total architecture of the subsurface. Then if you find out the surface architecture and subsurface architecture, the possible linkage, then possible linkage, and finally to brought out that is the hydrocarbon exploration. This is the broad methodology to identification of or the preparation of the various thematic layers and find out. That means end-to-end processing is there, in which flow that methodology you have to work, and such methodology we have derived to identification of the hydrocarbon exploration in that particular area. And for that, whatever data, because any case studies, if you are not giving that specification, the data, that does not mean any, that does not make any sense. So for that purpose, whatever data we require, we have taken that SOE data, that survey of India toposheet, and nearly about 21 toposheets we have taken for that particular region. And the satellite data we have taken, that is IRS P6. What is IRS? Yes, Indian Remote Sensing Satellite, and P6, that is the polar vehicle satellite. Yes, P6, the number is there, and LIS 4, that is the sensor. Linear imaging cell. What is the abbreviation for this LIS? Linear imaging cell scanning. And the LIS 4 having, what is the spatial resolution for this LIS 4? Spatial resolution for LIS 4. 5.8, not 5.8, 5.6. Okay, 5.6, and it is having pan merged. That is another sensor. One panchromatic image, it is fused to that one. Another is SRTM. What is SRTM? Shuttle radar topographic mission, which is having spatial resolution of 90 meter, and we are already used the different types of software, ArcGIS for the digitization and carrying out the such type of activities, then NV for carrying out the whatever for the processing of the images to find out whether the lineament is correct, whatever the mappings you are doing, whether it is correct or not, to superimpose for that region. And IPI 20 and VES, this is a software that is the vertical electrical sounding for the resistivity purposes, and IPI, that is induced polarization interpolation method. One method is there, induced interpolation method, and vertical electrical sounding. That means below the subsurface whatever the structures will come, that means automatically it will find out. Then another is the surfer. What is the necessity of this software? To preparation of the contour. Okay. So what is a contour? Because we already discussed such type of terms and terminologies. What is this? What is a contour? Very not. That is the equal elevation points from that mean sea level. And whenever you are getting all equal elevation points, and that line joining the equal elevation points is known as the contour line. One is the contour which is having the equal elevation points from the mean sea level, and whenever you are joining the equal elevation points, then it is called as the contour line. Okay, these are the base maps, and from this base maps, as I told you, the Konelu river is present in that northern direction, and subsequently there is coming from Cauvery, Kodamurti, Arasalar, Bhattar and Venar. These are the different types of rivers which is flowing from south to north, where the Venar is located near to your south position, and the Konelu river is present, that is your in north position. Okay. See, in that particular base map, you have seen that there is a typical shape is coming for that river. Okay. So if you are getting any particular, any drastic change of such type of shape, then what it indicates there? Particularly such area is coming under the tectonic activity areas. So particularly in that tectonic activity areas, what are the considering factors in which direction that fault is moving? Because this zone is very that seismic active zone. One is the seismic active zone, and another is your tectonic region. So for that region only, whatever the amount of sediments are coming and it is deposited near to that coastal area, or subsequently you are getting the broad arcuate shape of deltas. I will show you in the next figure. Yes. Comment to this image, that is the lithology map, and another is I am showing in the satellite imageries. See that in the two parts, particularly in the western part of the imageries, you see that there is the two uplands are there. Two uplands which is having some high elevation areas, and I have marked some zones which is coming this some yellow in color. This total area, this is your delta area, whatever the amount of sediments is coming from the different, because in between you see that numerous drainage patterns are available in this satellite imageries. So subsequently what is happening from that earlier history, when the river was present in this particular, because now the river is flowing this direction, now it is going to this towards migrating towards the northern direction, but earlier the river position was this area. Okay, earlier the river position was here only, and subsequently the rivers are migrating from towards north directions, from south to north direction. So what it indicates that, because if any water bodies will be migrated to that side, suppose one was flowing here and suddenly that is flowing there only, it is not flowing here, what it indicates there? Tectonic is the factor, then what it indicates there? That means this land mass is uplifting. Due to that uplifting, that means subsequent whatever the changes are coming. Okay. So these are the factors or the key signatures what you will identify from this satellite imageries. And if you will analysis broadly to identify the surface architecture or to bring out the surface signature of the surface. Okay. So as far as the lithology is concerned or the litho unit is concerned, there is the four types of lithology are present. In the western part, where the Patakutai and the Manargudi is there, and here the Joinkundam, two locations are there, the two uplands are there. This uplands, actually this is the region, and from this part, eastern part of this part Kotai and Joymkundam, suddenly there is the slope area, and there is a mega faults occurring in this particular region, that is the fault is coming in that north and south direction, which diverted or which is divided this area into two halves. One is your upland, another is your some the slopey area of the plain land. And due to presence of this upland and whatever the amount of sediments, because from this uplands due to the erosional process, whatever the sediments are coming, it is deposited this area. So subsequently this deposition and the tectonic movement indicates that there is the frequent migration of the such type of river. That means northerly migration of such type of rivers. Okay, and you are having the deltaic deposit in the center. That means, as I told you, as it is showing that arcuate in shape, arcuate, A-R-C-U-Q-A-T-E, arcuate. Arcuate means that the shape is coming from like arc, the Greek word arc. So it indicates that broad arcuate shape, and in between whatever the green in color, that means what we have identified, that is your fluvial marine deposits, because as you are having different rivers or the river patterns and coming to the coastal area, and this zone is known as the fluvial and the marine deposits, and another is your the total marine deposit near to the coastal area. So this area is the litho unit. As far the litho unit is concerned, this is divided into four major parts. One is your the sandstone, that is the in geologically what we are calling the sandstone with clay, that means in the age of Myo-Pliocene. This is the different types of ages in the stratigraphy, in geological stratigraphy. So this Myo-Pliocene sandstones are there, and the total, that is the center area where the delta is present, the deltaic deposit or the river deposit, and in between there is the interlink between the river and the marine, that means what we are calling the marine and the fluvial, and the total marine you are getting. Yes, for identification I am used that one. See, from this satellite imageries, if we will use, that is your visual interpretation technique. Visual interpretation technique. Can you identify any structures or any objects from this satellite imagery? If you will utilize your visual interpretation techniques or the skills. So what are the visual interpretation techniques or the skills? Visual interpretation techniques and the skills. Visual interpretation techniques and the skills. What are the visual interpretation techniques and the skills? That means we are using a formula for that one. What is that? That is T square SQ. Okay. Okay. T square SQ SAP. That is your tone, texture, shape, size, shadow, then site